Look up tonight. If the sky is clear, you'll see it, a pale, silent disk, close enough to seem familiar. Close enough that we've named every crater. Close enough that 12 human beings once stood on its surface and looked back at Earth. We thought we knew the moon. After 6 Apollo landings, after half a ton of rocks brought home and studied in labs around the world, we thought we had solved it. We were wrong. There is a problem with the moon that science cannot fully explain. A problem so fundamental it touches everything. The origin of Earth itself, the birth of the solar system, even the first conditions for life on our planet. A problem buried beneath the surface in a region so hostile, so cold, so absolutely untouched that no human has ever come close to it until now. Artemis III is going there, and what it finds may rewrite everything. If you're the kind of person who loves knowledge, subscribe and leave a like, because on this channel, that's exactly what we're passionate about. The problem begins at the beginning. Ask a planetary scientist how the moon was born, and they'll give you a confident answer. Roughly 4.5 billion years ago, a planet the size of Mars collided with the young Earth in a catastrophic impact. The debris from that collision coalesced into a ring around our planet, and over millions of years, that ring of rock slowly gathered itself into the moon. This is called the giant impact hypothesis, and it is the most widely accepted model we have. The problem is that the chemistry doesn't fit. When we analyze the Apollo samples, those precious rocks carried back between 1969 and 1972, we found something strange. The moon is chemically almost identical to Earth. Not similar, almost identical. The ratio of oxygen isotopes, the composition of certain minerals, they match so precisely that the numbers defy the model. If 2 separate planetary bodies collided, the resulting moon should show a mixture of both. But what we find is essentially Earth mirrored back at us from 384,000 kilometers away. Either our model of the collision is wrong, or there's a mechanism we haven't identified yet. We don't know which, and we need different samples. From a place Apollo never reached. Samples from a region of the moon so ancient it preserves the geological record of an era before memory. The first few 100 million years of the solar system, when everything was still being decided. That place is the South Pole. Picture the bottom of the moon, not the equatorial plains where the Apollo missions landed. The smooth, ancient lava fields that made for safe, flat touchdown zones. The South Pole is something else entirely, a landscape of extremes. Towering ridgelines that catch sunlight for months at a time. And between them, crater floors that have not seen a single photon of sunlight in billions of years. Scientists call these permanently shadowed regions. Because of the moon's nearly vertical axis, the sun never rises high enough at the poles to reach inside the deepest craters. The floors of some of these craters sit in permanent darkness. Temperatures dropping to minus 250 degrees Celsius, colder than Pluto. And over billions of years, something remarkable happened. Comets struck the moon. Asteroids struck the moon. These visitors from the outer solar system carried water, hydrogen, methane, all the volatile chemicals that evaporate quickly in sunlight. On the warm equatorial moon, that material boils off into space within hours. But at the South Pole, in those frozen, lightless craters, it stayed, layer after layer over billions of years, accumulated and preserved, locked in the regolith like a time capsule. One scientist described the South Pole this way. Imagine exploring an old house and discovering the attic. Everything that happened over centuries is still up there, untouched. The South Pole of the moon is the attic of the solar system. If that idea made something stir in you, hit subscribe. We go deeper every week. We know the ice is there. Orbital instruments have detected it. The L-Cross mission in 2009 deliberately crashed a probe into a shadowed crater and confirmed water ice in the debris plume. But we don't know how much. We don't know exactly how old it is. We don't know whether it arrived from comets, asteroids, or the solar wind. And we don't know what else is frozen alongside the water. What organic molecules, what clues about the early solar system might be sitting preserved at minus 250 degrees. We only know it's there, and we've never sent humans to look. There is a second mystery waiting at the South Pole, and it may be even older. Somewhere beneath the moon's southern region lies the oldest scar in the solar system. It is called the South Pole Aitken Basin. At 2,500 kilometers wide and 8 kilometers deep, it is the largest confirmed impact crater anywhere in the solar system. An asteroid struck here with such force that it gouged a hole nearly as wide as the continental United States and reached down into the moon's deep mantle. It happened roughly 4 billion years ago, and the exact timing matters enormously. Around that same period, there may have been a catastrophic bombardment across the solar system, the late heavy bombardment. When Jupiter and Saturn shifted in their orbits, destabilizing the asteroid belt and sending a wave of massive impactors raining down on the inner planets. If real, it would have repeatedly sterilized the surface of early Earth. It might explain the narrow window in which life finally took hold. But the evidence is ambiguous. The key to testing the theory lies in dating the ancient impact debris of the South Pole Aitken Basin, which recorded that moment of catastrophic violence in geological stone. That debris is scattered across the South Pole region, untouched, waiting. In the coming years, Artemis III will land astronauts within 6 degrees of the lunar South Pole. They will spend up to 6.5 days on the surface, walk up to 2 kilometers from the landing site, enter the edges of shadowed craters. They will be field geologists on another world. 3 instruments will be deployed. A seismometer, LEMS, will listen to the moon's interior, mapping the crust from moonquakes that never stop. LDA will probe the regolith for the presence and depth of ice deposits underground. And LEAF will plant seeds in lunar soil to test whether the moon could one day feed its own explorers. But the most consequential work will happen in the sample containers. The astronauts will drill. And the most ambitious goal, technically one of the hardest things NASA has ever attempted, is to bring back cryogenic samples. Sealed containers, kept impossibly cold for the entire journey home. So the ice doesn't sublimate, so the volatile chemicals don't escape. So that when the samples reach Earth, scientists hold material frozen since before our ancestors existed. If they succeed, we can date the water, trace its origin, know whether it came from comets or asteroids, and what that tells us about how water arrived on Earth and how life began. And if that ice contains complex organic molecules, preserved in cold darkness for 4 billion years, what we find at the bottom of the moon may answer questions we haven't even thought to ask yet. Here is what keeps planetary scientists awake at night. We have studied the moon longer than any other world. We have walked on it, driven across it, crashed instruments into it on purpose. It hangs in our sky, visible to the naked eye, and we see it every night without thinking twice. And we still don't fully understand how it formed. We still don't know the precise chemical story connecting the moon to the Earth. We still don't know the history of the ancient bombardments that shaped the conditions for life. We still don't know the full inventory of what's waiting in those frozen lightless craters. Every answer we've found has produced more questions. That is not a failure of science. That is science working exactly as it should. Tell me in the comments, Does it unsettle you that the moon, the most familiar object in the night sky, still holds secrets we can't explain? Or does that mystery make it more beautiful? I read everyone, because Artemis III isn't just a mission to the moon. It is an attempt to read the oldest chapter of a book we've only just realized we don't understand. Somewhere down there, in the cold and the silence and the permanent dark, the moon has been waiting patiently for someone to come and ask the right question. We are almost there. Keep looking up.